Welcome to The Explainer. Today, we're talking about a technology that you'll find in crime labs, in hospitals, even in ancient tombs. It's basically a DNA photocopier, and it was dreamed up by a scientist who was, well, both brilliant and deeply, deeply controversial. So let's start with a problem. I mean, this is the fundamental problem of genetics, right? Your DNA is this gigantic book, an almost unreadable code. And yet, one tiny little typo in there, just one letter, can cause a devastating disease. So how on earth do you find it? And this is exactly how Kary Mullis, the inventor we're focusing on, put it. That's how hard the challenge was. It felt completely and utterly impossible. Okay, so how did scientists try to solve this impossible problem? Well, before the 1980s, trying to find that one license plate, that single genetic mistake, was just an incredibly slow, clumsy, and frustrating process. The best they had was a technique called the Southern blot. And, just looking at these steps, you can probably see why it was kind of a nightmare. It worked, sure, but it could take days, sometimes even weeks, and it involved handling radioactive materials. This was not something you could use for quick, widespread testing. So, the solution didn't come from some big, methodical, super serious research team. Nope. It came from an eccentric biochemist named Kary Mullis, who was known for using LSD and who was frankly completely bored with his job at a little biotech company called Cetus. And yeah, Mullis was a known troublemaker, but his raw talent as a chemist was just undeniable. At Cetus, his job wasn't glamorous. He was the guy who made the tiny radioactive DNA probes, those little searchlights, for those slow, boring tests we just saw. He was support staff, not the star scientist. And this is where the story takes a huge turn. The company brought in a machine that basically automated his entire job. So all of a sudden, Mullis had a ton of free time and a whole bunch of leftover DNA snippets to play with. And that combination, well, it turned out to be revolutionary. So picture this. It's the spring of 1983. Mullis is on a Friday night drive up to his cabin. His mind is just wandering, thinking about those DNA tests and how to make the signal stronger. And then, boom, an idea just completely explodes in his brain. This was the big leap, the total game changer. He thought, instead of trying to find a needle in a haystack, why don't I just turn that one single needle into the haystack? Just make so many copies of the thing you're looking for that you literally can't miss it. What he came up with was a super simple, three-step cycle that basically copies how DNA replicates itself inside ourselves. First, you heat the DNA way up to unzip the two strands. Then, you cool it down a bit so these little starter pieces, called primers, can stick to the exact spot you want to copy. And finally, an enzyme called DNA polymerase just goes to work copying everything and making a perfect duplicate. And here is where the magic happens, because it's exponential. You repeat that cycle, and the number of copies doubles each time. 1 becomes 2, 2 becomes 4, 4 becomes 8, and he did the math. After just 30 cycles, you'd have this many copies, over 1 billion from just one starting molecule. He had just invented a DNA photocopier. So he gets back to the lab on Monday, totally buzzing, and nobody believes him. The idea just seemed way too simple. And let's be honest, Mullis was known for having some pretty wild ideas. His first experiments were messy, and they did nothing to convince his very, very skeptical colleagues. But his amazing idea had a really big practical flaw. The DNA copying enzyme they were using, which came from the common bacteria E. coli, just couldn't take the heat. It got destroyed during that 95-degree unzip step. That meant a lab tech had to stand there and manually add a fresh, expensive drop of it every single time. It totally defeated the purpose of having a simple, automated process. But here's the crazy part. The solution had already been discovered 20 years earlier, just sitting on a shelf, basically. A microbiologist studying the hot springs at Yellowstone had found this amazing bacteria, nicknamed talc, that just loves living in boiling water. And its enzymes, including its DNA polymerase, were naturally built to survive extreme heat. And wow, look at this. This slide just shows you the breathtaking difference that enzyme made. When the team at Cetus finally tried the Taq polymerase, the results were like night and day. On the left, you see the messy, smeared results with the old enzyme. But on the right, Taq loved the heat. It cleared away all the background junk and created this perfect, clean, unmistakable signal. This was the holy grail. This is what made PCR an easy, automated reality. So, the invention is a massive success. And then what? Well, in 1993, Kary Mullis was awarded the Nobel Prize in chemistry. But He took all the credit. He basically wrote the team at Cetus, the people who did all the hard work to make his flawed idea actually work, right out of the story. It became his invention and his alone. And after winning the prize, Mullis pretty much stopped being a scientist. He used his fame as a megaphone for his increasingly strange ideas. He talked about everything from alien abductions and glowing raccoons to starting a business that sold jewelry made from the DNA of dead celebrities. But not all of his ideas were just weird. Some were incredibly dangerous. He became a leading voice denying that HIV causes AIDS. And because he was a Nobel laureate, his words carried weight. They gave this deadly misinformation a kind of scientific cover, which influenced policy in South Africa and led to just catastrophic real-world consequences. Kary Mullis passed away in 2019, and he left behind this incredibly complicated legacy, to say the least. But his invention, now totally separate from the man, has, without a doubt, shaped the world we live in today. I mean, think about forensics. Its power there was just revolutionary. PCR lets investigators take a microscopic trace of DNA from a crime scene, a single hair, a tiny drop of blood, and copy it until they have enough to identify a criminal, or just as important, to prove someone is innocent. In medicine, the impact is everywhere. It's the key technology we use to find genetic disorders, to screen for cancer markers, and to quickly diagnose viral infections, like HIV, the very same virus he's so dangerously denied. And then, in this unbelievable twist of historical irony, just 1 year after he died, Mullis's invention became the gold standard test used all over the globe to track and control the spread of the COVID-19 pandemic. It literally touched billions of our lives. Today, the applications are practically endless. We use it to study DNA from ancient mummies, to develop new vaccines, to reunite families that have been separated, to keep our food safe. The list just goes on and on. That simple idea of a DNA photocopier is now a fundamental tool of our modern world. So Mullis's story really leaves us with this powerful idea, and it's one that's super relevant right now. His world-changing breakthrough only happened because a machine took over his boring, routine job. It freed up his mind for the kind of creative, imaginative thinking that leads to real innovation. Which really makes you wonder, doesn't it? As automation starts to handle more and more of our work, what kinds of revolutions might it unlock for the rest of us?